Okay, this is probably one of the most difficult problems you'll encounter in your algebra class or test in high school, where you have to find the axis of symmetry in accordance to the vertex of this type of parabola. And there's really no friendly or easy way to go with your roots or anything. Let's start with the axis of symmetry, though, because that's an easy starting point. Axis of symmetry, how do we find that? Well, what I would do is graph it and look for that symmetrical line. But if I had the shortcut at my disposal, which is to take the b term, and take the negative of that divided by 2a, that's how I would find my axis of symmetry in one of those ways. So here's what we'll use. We'll use this approach, and it's something you'll want to hold on to for your exams around these kind of problems. So this just means that your axis of symmetry equals the negative b over 2a. And that just refers to the fact that when you're given a quadratic formula in y equals ax squared plus bx plus c form, you could just take your b term, right, invert it and divide it by twice the a term. So in our case, they give us y equals negative 2x squared minus 8x plus 3. Okay, well that just means that our a term here is equal to negative 2, and our b term is equal to negative 8, b is negative 8, and our c term right here is 3. Okay, so that means that our axis of symmetry is negative b, negative 8, over 2 times negative 2. And what's that? Well, negative 8 is 8, over 2 times negative 2 is negative 4. Finally, our axis equals negative 2. And I'll write x equals negative 2. This just means if you have your graph, you can almost picture the graph of this parabola. Our a term is negative, right? Okay. So our axis of symmetry is equal to x equals negative 2. Right here. Okay. Well, here's the idea next. Once you have this, you can find your vertex. And there's lots of ways to find the vertex. Some are really complex at this introductory level. You get to complete the square and do all this stuff. But realize that your axis always goes through your vertex, always. That's a wonderful property. So if this axis is at x equals negative 2, if I plug in, right, x equals negative 2 into my function, what am I going to get? Well, if you plug in negative 2, that's going to give you this point here on the graph, right? When you plug in those x values, you get the heights of the graph at that x value. So you could actually get the vertex. So that's it. Plug in x equals negative 2 into your formula. So y is equal to negative 2 times negative 2 squared minus 8 times negative 2 plus 3. All right, well, negative 2 squared is 4 times negative 2 is negative 8 plus 16 minus negative 16 plus 3. So y is equal to what? Well, 16 plus 3 is 19, minus 8 is 11. Y equals 11. So the vertex is negative 2, 11. So I only say this one's so difficult because it requires this conceptual connection that when you find the axis of symmetry, right, and you'll need this formula to save yourself plenty of time, negative b over 2a. Once you find that, it gives you the x value needed to find the vertex. All right, hope this helped.